Okay, so we're going to start. Okay, today we are still going to continue with heat. I think heat is a topic that can be really quite difficult to grasp. Okay, but with enough practice, I think we can get there. Okay, I've seen all your responses. Those of you who have attempted your homework, very well done. I've noticed that there can still be quite a handful of questions that you don't get correct. Okay, so for the three of you, okay, I know you three have really put in the effort to do your homework, and I really appreciate that. But at the same time, I think at least you try. I think that's the very good first step to take. Okay, at least you try the questions. But at the same time, I realized that I think you all got almost half wrong. So that tells me that you are still not very sure about heat. I think maybe because heat is still a very new topic to you. Okay, so that means we really have to go through more of the concepts. Yeah. Okay, so let's quickly go to that. Okay, just some recap, some key points. Okay, heat is a form of energy. It's heat energy, right? It makes things warm. It's given out by heat sources. Okay, so some examples of heat sources. This is just a quick recap, yeah? Of course, our main source of heat is the sun. Okay, some other sources of heat can be like, for example, a candle flame, right? A torch light, for example. Okay, I think I might just have to remove your annotation because, like I said, your annotations will not be saved. Okay, because it's just on Zoom. So I think I'll just clear it. Okay. Okay, and then another concept is temperature. Okay, so you need to understand that heat and temperature are not the same thing. Okay, heat is heat, and then temperature, okay, is actually a measurement. Okay, temperature is a measurement of how hot the object is. And it's usually in Singapore's context is measured in degrees Celsius. Okay, so all in all, what I want to say is that heat is not equals to temperature. Heat is a form of energy. Temperature is a measurement of the degree of hotness of an object. Okay? Okay, next thing. Very important thing is you need to know that heat always flows from a hotter region to a colder region. It's always from a hotter object to a colder object until both of them are until both at the same temperature. That means they reach equilibrium. Okay, heat will always travel from a hotter region to a colder region until they reach the same temperature. Yeah. So in this scenario, the colder object gains heat from the hotter object. Okay. The hotter object loses heat to the colder object. So we always use the term either, okay, maybe I use another color. We always use the term either gain heat or loses heat. Okay, gain heat or lose heat. We do not use gain coldness or lose coldness. Okay, we always say gain heat or lose heat. So you must always ask yourself, where is the hotter region? Because the hotter region is the region that is going to lose heat. Then the colder region is the part whereby it will gain heat from the hotter region. Okay? So it's really important to use the correct terms when it comes to explaining the transfer of heat energy. Okay, please do not, like I said, do not invent your own terms like gaining coldness, no such thing. Okay, or even right, or even lose coldness. Okay, no such thing, yeah. Okay, so let's take a look at the sample question. Image below shows a cup of hot coffee. So ask yourself, where is the hotter region? Where's the colder region? Anybody? Kelvin, where's the hotter region?
The hotter region is the hot coffee.
Very good. The hotter region is hot coffee. Abriel, where's the colder region?
The cup.
Yeah. The colder region can be the cup, it can be
Or
the
the bowl.
saucer, it can also be the surrounding air.
Can it also be the bowl? I mean the plate.
Yeah, the saucer can. Okay, it can also be the surrounding air. So the colder region are all these three. Yeah. So when it comes to explaining how the cup became hot, okay, now they do not ask us to compare surrounding air and saucer. They are only asking us to compare between the cup as well as the hot coffee inside. Okay, so in this case, you can say that the
Cup gain heat from the coffee.
very good. You're using the right term. The cup gain heat from, you must always say gain heat from who? From the hot coffee.
In the
And
cup.
yeah, and became hot. That's all. Okay, the cup gained heat from the hot coffee and became hot. Yeah, so that's how you can answer this question. Are we good? Yeah, any questions? No. Okay, I see Kelvin violently shaking his head. Okay, very easy for you, Kelvin. Yeah. So the cup gain heat. So this is the key phrase that you're supposed to put. Gain heat from who? From the hot coffee. And became hot. Okay. Now next question. Susan measured the temperature of coffee over 30 minutes and recorded her results in the table below. Explain why the temperature decreased over 30 minutes. Okay, you notice the temperature is going down, decreasing. So why the coffee start to decrease in temperature after 30 minutes? Yes, Kelvin.
Maybe because the coffee lost heat to the surrounding air.
Very good. The hot coffee lost or loses heat to the surrounding air, causing the temperature. Must always link back to the
To
question, yeah?
decrease.
Very good. Okay, to decrease. Okay, see? The cup of coffee lost heat to the surrounding air. This is the key phrase that you have to have. Then, of course, you can link back to the question, causing the temperature to decrease. Now, my next question to you is, why is it that the temperature stays the same for 25th to 30th minute? Why? It never decreases, 30 and 30. Anyone?
Maybe it is the coldest it can go.
Okay, good prediction. What about you, Aber?
Maybe because like at the 25 minute and the 30 minute, both of them reach to the room temperature.
Very good. Yes. Okay. So if let's say such a question were to come out, the reason is because, okay, oh yeah, why is it in yellow? Let me see. Okay. Okay, the cup of coffee, you can just write, okay, if they were to ask you why is it that temperature remains constant, the cup of coffee has reached room temperature. Okay, it basically, there's no more difference in terms of temperature. So there's no heat gain or heat loss anymore. They just stay at the same temperature as the surrounding air. So it has reached room temperature. Okay, so far? Yes? Okay, now let's move on to the next one. Okay, we'll do first 10 questions first, then later on I'll give you a short break in between. Yeah? Okay, so let's start with question 1. Yes, Abir.
The answer is D.
D for dog, is it?
Yeah, D for the
Yes, good. Okay, when you're doing measurement, okay, it has to be the bulb of the battery. So these two are out because these two, the bulbs are here. So this one is wrong, this one is wrong. Then this bulb is
A is not
outside.
even inside the water.
Yeah, A is not even inside the water. That's the thing. Okay, so to measure temperature properly, the bulb must be inside the object that you are measuring. Yeah. Okay. Next one is an open-ended question. Rashid, and I noticed that a lot of you left it blank though. Okay, so maybe you just want to share with me what are your
Never
concerns,
left
okay?
it blank.
Yeah, except for some of you lah. I think most of you left it blank. Okay, now Rashid conducted an experiment using setups X and Y as shown below. He wrapped a glass beaker with material A and another identical glass beaker with material B. He filled both beakers with the same volume of hot water. Okay, so the only difference in this experiment is the type of material. One is material A, one is material B, right? Rashid measured the temperatures of the water over a period of time and plotted his results in the graph shown. So what happened to the temperature of water in setups X and Y after some time? So basically this question, right, you just have to describe. Okay, what happened to the temperature of water in both setups X and Y? Both the temperatures decrease. Yes, so to write down the answer, they both decrease, and not just that, eventually they both decrease and eventually reach room temperature. See? Right? So it's not keep decreasing, never ending, right? It's basically they will decrease, and eventually, of course, they reach the room temperature because there's no more temperature difference between the room and the water. So it reaches room temperature. Anybody writing down? Ariana, you okay? Can't see Ariana. Let me see. Ariana, you okay? Yeah? Emma, you fine? Okay. Okay, let's move on. Okay, next question, same question. Explain why the temperature of water in setup Y decrease at a faster rate. If you notice, this setup Y goes down even faster and it reaches room temperature faster. Okay, so what does that tell us about the material? Because in setup Y, the material that is covered is material B.
And then it is dark in color, so you lose it slower.
Well, if it loses slow, how come the temperature goes down so fast?
Because like dark color materials are always lose heat slower.
Yeah, then if it lose heat slower, that means the temperature of water should not decrease so fast. I think you're a little bit distracted with the color. Okay, sometimes you have to ignore the color. It's not really about the color. Sometimes
Because
they use
setup Y is a good conductor of heat.
yes, because the material B in setup Y is a good conductor of heat. What I was saying just now is that sometimes the color is just there to show you that they are different materials. It doesn't really mean that it's definitely black. Okay, but what is real is that look at the results. Okay, what is real is that it is true that the temperature of water in setup Y really decreased faster, right? As compared to setup X. Setup X only reached room temperature here. But the material in setup B helped the water to decrease so fast. So like what Abir said, yes, okay, because material B is a good conductor of heat. Yeah. So what if it's a good conductor of heat? For explanation question, you must have claim, evidence, reasoning. Okay, so in this case, your claim is that material B is a good conductor of heat. Your evidence, where is your evidence? Usually evidence, you have to refer back to the results. So in this case, the
gains
results.
heat from the hot water faster.
Correct. Yes. So this is it.
My
Okay, so
reasoning is and the temperature of the heat water decrease faster.
yes. Okay. Actually, for this one, it's a little bit swapped around. The temperature, this one seems more like the evidence. Okay, because the evidence is in the graph, we can see that the temperature decreased faster. Now, the gain heat part actually is the reasoning. So depends on how you phrase it. But as long as you have your claim, evidence, and reasoning in your answer, you should be fine. Are we good? Yeah? Any questions? Kelvin's writing down, right, Kelvin? Aber, are you at the beach? You look like you have like sunglasses in your